if you have a binomial distribution, reminder that binomial distribution has a failure and a success and a certain number of trials, like flipping a coin 15 times. Then the mean of a binomial distribution, which is the same as the expected value, is just the number of trials and your probability of success. For example, you have a multiple choice test. It has 20 questions. Each question has A, B, C, and D. You decide to guess on the whole test. What would you expect to get on that test? Well, you had 20 questions, so that's your number of trials. What's your probability of success on any one question? 1 out of 4. 20 times 1 out of 4 is 5. You would expect to get 5 right. That would be the average. You could get lucky and get more than 5 right. You could get unlucky and get less than 5 right. That's such a great example. Is it a good idea to guess on an entire test? 20 questions. We can go to our calculator. We can set up this binomial distribution by going distribution, binom PDF, 20 trials, probability of guessing right would be 1 out of 4. I'm not going to do which specific one, so it does them all. Push enter. How many answers will it give there? If I had 20 trials, 21, because it could be 0 right up to 20 right. Just like in a binomial expansion, always one more term than the exponent. There's always going to be one more in a probability distribution than the number of trials. So there's 21 answers there. I'm going to store them into list 2. Okay? And we already talked about the average, what your expected value would be to get 5 of them right. Now, if we go to our stat list right now, your chances of getting 0 right are 0.3%. Can you see that the highest probability is 5? That's our mean, that's the expected value. You have a 20% chance of getting 5 right. Okay? If we look further, right? Look at these. Oh, I should write 11, 12, 13. Some math we can do with this. We can now figure out if you guessed on the entire test, what are your chances of passing? Well, you have a chance, right? It's possible to pass. You could guess 10 or more right. But now that we've got this binomial distribution, you can actually find the probability of passing. Because if we think about this example, here's x, probability x equals x. Start with 0, 1, ... 19, 20. If you wanted to find out the probability of passing, does it make sense that you'd have to add up all of these until you got back to 10? And so I could say 100%, because that's what this all adds up to, minus binom CDF, 20 trials, probability of success is 4, and binom CDF adds up to a number, so we could add up to 9. So I'm going to go to my calculator, just show you how you could do that. Again, go to distributions, binom CDF, 20 trials, probability of success, adding up to the 9th one. Oh, I should get out of this screen. Divided by 4. 1 minus my answer, you've got about a 1% chance in passing. In other words, if I had a class of 100 people, I gave them 20 multiple choice questions, and I said guess, I would expect one person to pass. But it's not guaranteed. Still might be that nobody passes. But the expectation is 1% should pass their test. So as far as the strategy going into tests from now on, right, you're not going to say, oh, we did our math, I found out it's way better just to guess on everything than to study. No, that's not true. That's not going to help you. But now you can actually figure out what are your chances. And 1 out of 100 isn't very good, right? Variance of a binomial distribution. So we have formulas for the mean. We also have formulas for variance. These are on our formula sheet as well. The variance is your number of trials times the probability of success times the probability of failure. And then if you take the square root of that, you can find your standard deviation. Good, ready? Almost. Okay, so here's our first example. An urn contained seven marbles, of which 2 are blue. So I read that first sentence, and I actually think this starts to sound like a regular probability question, kind of like maybe I'll draw a tree diagram. A marble is selected, you look at its color, and you put it back. So that would be one branch. You could get blue or not blue. And then again, blue or not blue on the next branches. But this is done 50 times. Can you imagine your tree diagram 50 times, each time having 2 branches on top? Can you imagine how many branches would be in the end? Lots. 2 to the 50. That's a big number on your calculator. Okay? So because we have a number of trials, 50 times, you've got get blue or not get blue, a success or a failure. This is a binomial distribution. The biggest thing in these questions is your ability to, when you read them, to know, oh, it's a binomial distribution. So that recognition is huge, because now you have a set of formulas you can use. You have programs on your calculator that you can use. Then you want to find the probability that 10 blue marbles were selected. Okay? 50 trials, probability of success 2 sevens. Easiest way to do this would be to go to your calculator, type it into your calculator. Chances to 3 sig figs, 5.32%. Again, you also have on your formula sheet this formula. You could type that in as well. But there's more calculations. And since you have a calculator anyways, I recommend the second one. That being said, sometimes an IB exam will say, too many students are just using the calculator and don't understand the formula. So we'll design a question that makes you have to use the formula some way and show that you understand it. So yes, the calculator is nice, but we still have to understand how the formula works to figure it out. What's the mean number? Well, it's a binomial distribution. The mean is just number of trials times probability of success. So we had 50 trials. Probability of success is 2 out of 7. On average, you should have got 14.3 blue marbles. Of course, you can't actually get 0.3 of a blue marble, but as an average, this is what you would expect. And then part C, find the standard deviation. Again, your variance is on your formula sheet. I put Q in for failure. You could write 1 minus P as well. So again, if you know what formula to use, there's really not very much math that you have to do. It's just plugging things into your calculator. That's relatively easy. So in this part of the unit, it's really about recognition. Recognizing this is a binomial distribution question. I know the properties of a binomial distribution. And then after that, it's just putting things into the right formula. Okay? If you don't know the properties of binomial and you don't recognize it, it can be catastrophic because you go and use wrong formulas, and then there's no marks that can be had.